All right, so now we're starting with question 72. Basic answers to question 72 to 74 on the passage and data table below and on your knowledge of earth science. The data table shows the monthly average high air temperatures in degrees Fahrenheit and monthly average snowfall in inches at the summit top of Mount Washington in New Hampshire. All right, and so we know that this passage is about Mount Washington. Just looking at the first sentence, we know Mount Washington, located on the state of New Hampshire, is one of the highest mountains east of the Mississippi River. So we know that this passage is about a mountain. All right, so keep that in mind. So 72, it says on the grid in your answer booklet, construct a line graph by plotting the average high air temperatures for each month listed in the data table. Connect all 12 plots with a line. So while you're plotting, right, you want to make sure that you're only plotting the average high air temperature. And when you look at the answer sheet, your plot should look like this, all right, where your lines are connected. All right, I will post the answer sheet on, attach this on Teams so that way you'll be able to compare to make sure each value matches up as well too. All right, you're just matching up to make sure that you're accurate. You should be double and triple checking because this is an easy question to get credit for. Okay. Number 73. So number 73 says, identify the climate factor that best explains why Mount Washington has relatively low air temperatures throughout the year. When we're saying low air temperatures, what are we talking about? Low air temperatures means that it is cold. Why is it that Mount Washington has cold temperatures throughout the entire year? Why is that? Well, Mount Washington is a mountain. And what do we know about mountains that attribute to having cold temperatures is that it has high elevation. All right. If you said high elevation, if you said high altitude, that's fine. If you wrote, I'm going to show you the answer key. If you wrote that, oh, because it's a mountain, you would not get credit for that. If you wrote that, oh, it's on top of a mountain, you would not get credit for that. The special thing about a mountain is that the climate factor is elevation, altitude, or the height. That affects whether or not you're going to be in a location that is very cold. So that's something you have to keep in mind. For number 74, all right, number 74, and it states, state the name of the geologic epoch when continental glaciers last carved the valleys around Mount Washington and across upstate New York. All right, when glaciers last carved the valleys around Mount Washington and across upstate New York. So geologic epoch is on what page of the reference table we're going to be using? We're going to be using page 8 and 9. All right, so we're going to look for page 8 and 9. Page 8 and 9. All right, and so when we're looking on page 8 and 9, what we are basically looking for, hold on, let me just make sure everything matches up. Okay, apologize, I'm just gonna move the screen. There we go. Okay, so when I'm looking through page 8 and 9, there's only one factor that I noticed that talks about continental ice, right? Last continental ice, glaciers, glaciers that are moving. And it's stated right here. See where it says advance and retreat of last continental ice. And we know these are important events in New York, so it makes sense. When I follow this line to the epoch is located on the bottom, the epoch that you can see is the Pleistocene epoch. So the correct answer is located right here, Pleistocene. When you follow that line, it lines up with Pleistocene, right? Not the Holocene, Pleistocene. All right, and that's why a correct answer is going to be right here, the Pleistocene era or epoch, right here. Okay, let's move for the next question. Number 75. So number 75, it says base the answers to questions 75 to 78 on the table below and on your knowledge of earth science. The table shows the velocities in kilometers per second for several galaxies represented by letters A, B, C, D, and E that are moving away from Earth. The vast majority of stars and galaxies in the universe are moving away from our solar system. Scientists' evidence indicates that the farther away a galaxy is, the faster it is moving away. List the galaxies in order, 75. List the galaxies in order from closest to farthest, closest to Earth to farthest from Earth. Well, the background reading is stated right here. Scientific evidence indicates that the farther away a galaxy is, the faster it is moving away, right? The farther away a galaxy is, the faster it's moving away. So whichever galaxy is moving the fastest is the one that's going to be the farthest away. So which one is the farthest? I already know A is the farthest. And which one is the closest? C is the closest to Earth. How do I know that? Because it's stated right here. The farther away a galaxy is, the faster it's moving away. And so you're listing it from closest to farthest. So your first letter is going to be C, right? Is going to be C. Then which is the next bigger number? Is going to be B with 15,000, right? Then after that, it goes to E. Then the next biggest number is D. And then last is A. So it should be C, B, E, D, A. Listing the galaxies from closest to Earth to farthest to Earth. C, B, E, D, A. So basically, you're going from the smallest velocity to the biggest velocity. Let's take a look at number 76. Identify the name of the theory for the formation of the universe that scientists developed after observing that most galaxies are moving away from each other. This is something that you should know, this theory, right, of how scientists believe how everything was created is none other than the Big Bang Theory. The Big Bang Theory. This is something that you should know. All right. And then number 77. It says, identify the evidence used to determine that a galaxy is moving away from Earth. Remember when we talked about what type of shift does the light show if it's moving away, right? If it's a moving away from Earth, it is known as a redshift, right? It's a redshift of light. Red shift means moving away. Blue shift means coming closer. And most galaxies are showing a red shift of light. You could have mentioned any of these other answers as well. So you could have mentioned that the study of the Doppler effect, redshift. You could have mentioned that. You could have mentioned the wavelengths of the light from the galaxies appear to be longer. The spectral lines are shifted towards the red end of the spectrum, and the Doppler effect shows a red shift. Any of those would be acceptable. All right. Now, next, for 78, it says a star in one of these galaxies has a surface temperature of 8,000 Kelvin and a luminosity of 10. Identify the stage and color of this star. All right. So, what page of the reference tables shows the characteristic of stars? What page of the reference tables? So, when we take a look, we're looking at page 15. So when you turn to page 15, right, and we want to know what a star in one of these galaxies has a surface temperature of 8,000 and a luminosity of 10, identify the stage. All of these that we see right here, supergiants, giants, main sequence, white dwarfs, these are all stages of stars. We need to know the correct stage and color. Stage and color. So when we take a look, 8,000 is right here, luminosity of 10. When I match it up, it's located on the main sequence stage. So as far as stage, your stage is going to be main sequence. That's the first thing. Your stage has to be main sequence. What color is it? The color's below, and the color is white, right below temperature. So if you said white and main sequence, you are correct. You have to have both of these in order to get the correct answer. There's no partial credit. So if you said main sequence in a different color, it would be wrong. You have to be main sequence and white.